pi bonds. So let's take a look at the ethylene molecule. Okay, so it's got 5 sigma bonds and 1 pi bond. So it can be either the top one or the bottom one, it doesn't matter. Okay, and pi bonds are formed by the sideways overlapping of p orbitals. So how does it come about? So if you take a look at carbon's electronic configuration, so it's got 1s2, 2s2, and 2p x1, 2p y1. This is under normal condition. But when carbon undergoes what is known as hybridization, of course the inner ones, they're not participating in any electron transfer reactions. The 2s electron, it goes into the vacant p orbital, okay, and it forms this. So now these, the 1s, the 2s and the 2px1, 2py1, they form what is known as hybrid orbitals. Okay. So what does the hybrid orbitals do? So the hybrid orbitals, so they form something like this, and at a bond angle of 120. Yeah. So these are known as the sp2 orbitals. And now another hydrogen atom can come along and it can form bonds here, and then one of the bonds is formed with the carbon here, because this is the carbon here forming bonds on either side with hydrogen, and then it is making a bond with the carbon here on the other side, and something like that. Okay, so carbon's valency is now 3, but we know that it's got a valency of 4. So how do we get the fourth one? So from the electronic configuration, you see that there is one unpaired orbital just lying about like that on carbon. Yeah, that's unhybridized, and that was the 2pz1 orbital. So this unhybridized orbital, they can overlap sideways, so as though it's making a bond sideways. Yeah, and that's why this one is known as a pi bond, and it is quite rigid because it doesn't allow the movement of bonds, unlike single bonds. Okay, so that's the pi bond, and sigma bonds are the rest of the ones.